up, Mr. Kern here. This is lesson 24, electron configuration, which sounds really scary, so we're going to ignore that and call this the electron cloud model. We've been doing the Bohr model with the shells, with the electrons on them. This is the more correct version of it. And with it, instead of looking at shells, we're going to look at subshells. So there are shells inside the shells that you never knew about because they didn't want to tell you yet. So first off, you need to be able to compare the Bohr model to this model. So pause the video and draw out all the rings and the electrons for argon, and then we'll talk about that. Alright, so we know with this, it has 3 shells because it's on the third period. It has 8 valence electrons because it's in the last column. And so it's 2 plus 8 plus 8. That is a total of 18 electrons, which is what we're supposed to have for that. So it's pretty simple. Alright, so now I want you to draw the same thing for krypton. So realize it's in the next period down, still in the same column, and so it has a total of 36 electrons. So pause the video, draw that. So what you have might look something like this. You know it has 4 shells because it's in the 4th period. You know it has 8 valence electrons, and then basically you fill everything else in. So it's 2, 8, 8. So altogether that equals 26 electrons. Oh, but wait. It was supposed to have 36. So you're missing 10. What's up with that? What's different about this column, or this row, compared to the rest? Well, we've got these in here, and if you count, there are 10 electrons right there. So, when they told you, back in the day, when you were learning this stuff, you can only have 8 electrons in a shell, they were kind of lying to you. You can only have 8 in an outer shell, but the inner shells can get more than 8. And they didn't want you to know that because that would be confusing. But now I have to teach you, and it is confusing a little bit until you get the hang of it. So we're going to have to relearn just a little bit, and the idea of subshells, the idea of having shells within these outer shells, basically it kind of clears up the confusion on it. So that's what we'll look at next. So the difference in the electron cloud model compared to the Bohr model is instead of it just being rings, it's really like 3D spheres. And so there are different types of shapes that the electrons can live in. You have the S shape, or the S orbital. Those can hold 2 electrons. Each one of these that's drawn can hold 2 electrons. So there's only one kind of S, so it only holds 2. The P comes next. Oh yeah, don't draw these out on your notes. That would be ridiculous. So you don't need to know exactly what each one looks like, just the idea of a general picture of, okay, it's kind of the weird, crazy figure 8 kind of shape. The electrons just buzz randomly within each one of these, and so this has 2 electrons buzzing randomly in here, another 2, so P will hold 6 electrons. A D orbital will hold 2, 4, 6, 8, 10. That one's kind of funny shaped. And an F orbital will hold 2, 4, 6, 8, 10, 12, 14. And so instead of like the shells holding 2 and then 8 and then 8 like you've learned, it's a little bit different. Which I think we'll get back to after we talk about some other stuff, exactly what that difference is in drawing these. So, with the Bohr model, or I guess comparing the subshells to that, each of the Bohr model's rings is made up of subshells. So all we've ever drawn are just, like the first shell holding 2, and like I said, second shell holding 8. But those 8 electrons live in 2 different places. We've drawn them all together. So the subshells represent the S, P, D, and F orbitals that we just learned about. Okay, and so really in general, if I were you sketching this out for your notes, I would just draw a nice box there. with straight sides. One there, and then one here. Now realize also, this guy right here actually lives over here in this spot. So helium acts like it lives here. And then you have this last. So you can see these with the labels. You have the S block, the P block, the D block, and the F block. So for your notes, you should just basically have that sketched out. And so when we compare it to the Bohr model, if we're going to draw our argon, in the Bohr model we draw the first shell with 2 electrons. In the electron cloud model, or with the subshells, if we look back on the orbitals there, the S subshell only holds 2 electrons. So for us drawing the S subshell, it's just going to hold 2 electrons. It's pretty simple. And so after we do that, we added 2 electrons. That puts us through this spot and this spot, or through there and there. So as we add electrons, we just go basically block by block through the table. And so now that brings us down to the next spot. That's where in our Bohr model we draw another shell, and then we would go ahead and draw 1, 2, 3, 4, 5, 6, 7, 8 electrons. We're just going to draw an 8 there. We would draw 8 electrons there. In the electron cloud model, I'm going to do it a little differently. In the electron cloud model, the next shell, as you go across here, look at what it's made out of. This entire shell is made out of an s orbital and the p's. So, if I go through an s orbital, which holds 2, and a p orbital, which holds 6, if I go all the way through that, that equals 8. So when I drew this one shell holding 8, that's the same as if I drew a small shell holding 2 and another shell holding 6. So the first 2 electrons get put into the S shell, or the subshell. Then the next 1, 2, 3, 4, 5, 6 get put into the 2p. Okay, so what we can also do is we can keep track of these as we go. So first we put in, we went through the 1s. So the first period, the S group. So we put the 1s. How many electrons did we put in there? Well, we went through the whole thing, so we had to put in 2. So that worked us through our table up to here. Then it's like a typewriter. A typewriter is the thing you used to type on before computers came out. And it gets to the end, you ding, now you go back to the beginning. So what are we going through now? We're going through the 2s. How many electrons do we put into the 2s? If we go all the way through it, we put in 2. So we'd say 2s, and we put in 2. We keep going all the way through the table, and we end up going, in order to get to argon, all the way through the 2p. So we hit the 2p. We put in 1, 2, 3, 4, 5, 6, because it's full, electrons. So in total, if you look at the 2s, you have 2 plus 6, so it's a total of 8 electrons on the second shell. So that's the shell number. That's the orbital number. So maybe write that down. A big 2s2. So that number is the shell number, the period number. That is the orbital, or you can look at it as the block. So what block of the table is it? That's the S block. And then that is the number of electrons put into that block. So if I stopped here, that would be 1s2. I went through that whole thing, went through 2s2, and this would say 1, 2, 3, 4, 5. 2p5 would be what I'd write down there. So it's just however many you put in. You put in 6 to get to argon, it's 6. If you stop here and only put in 5, it's 5. Alright, so keep going to argon. On our regular picture, we draw a third shell. On that shell, to get to argon, we would put in another 8 electrons. So we have 2 plus 8 plus 8. That equals our 18. For the electron cloud model, we go through the third shell, we go all the way across, and so we went through the 3s first. You'll kind of see, patterns after a while. You do the same thing over and over. Just going to draw kind of a half ring. So I went through this would be the 3s. I put 2 electrons into it. That's all I can hold, and I put them both in there. So I went through the 3s, I put in 2. Then you keep going across, and you go 1, 2, 3, 4, 5, 6 on the 3p. So again, inside the third shell that holds 8, I really am putting on 2 and then another 6. And so 3p 6. I need to have 18 electrons when I'm done. I have 2, 4, 10, 12, 18. So the top numbers, the number of electrons, because that's what it is, number of electrons, should add up to 18 when I'm done. So this so far isn't the confusing part. Well, hopefully not too confusing. What was really confusing is when we get down here. Okay, but pause real quick. What we wrote down here, it's kind of like directions. If you want to tell somebody directions to get to your house, you say, okay, so start here at the beginning. Whoa. Start here at the beginning, and then you go through this place, and through this place, and through this place, and you're going to end up here. And so that's what we did. What we just wrote down is called the, at the beginning, that is the electron configuration. The electron configuration is basically a list of all the electrons and where they live. That took way long to write. A list of all the electrons and where they live. So, for example, it would just be like 1s2, 2s2, 2p6, 3s1. So, where they live, 1s2, 2s2, 2p6, 3s1. That means I stopped on 3s1. So let's look what that is. 3s1 would be right here. So that is sodium. So that is the electron configuration for sodium. A list of all of its electrons, 1, 2, 3, 4, 10, 11. So you can just look, okay, it has 11 electrons. That must be sodium. All right. If we continue on, so let's just say we have the first 3 shells full. So we're ending up with 3p6. If we continue on from there, so we've gone through all that, we want to continue on to argon. We have to go next through the 4s2. So we're going to add another shell. Again, we have all the inner ones. There's the first, second, third, and now we're going to add 2 on the 4th shell. There you go. 1, 2. That puts us right here. So from what we had before, it was 4s2. Now, if you look at the table, what do we go through next? We go through the 3D. So, what does that big number tell us? The big number tells us that's the period number. So that means our period is 3. Even though we're on the 4th shell, these electrons go to the third period. So the next 10 electrons get put back on here. So this is already full. It already had 8. But after you add 10 more, now this shell can really hold 18, which they told you before was against the rules. You can only hold 8. But after you put 2 on the 4th shell, it can go back in and hold more. That puts us right here. So what do we enter next? We enter the 4 P's again. So we go through 6 4Ps, and so along with the 4s2, we'd have our 3d10, and then 4p6. We have another 6 electrons on that p bond. Alright, so I'm going to give you some examples. Pause, see if you can do it, then unpause, see if you're right. Alright, so I want you to draw and then give the configuration for, let's go with boron. Boron lives right there, so it's element number 5. Alright, so for boron, just look at it like you're taking a walk through the table. So you go through this layer first. So you went through the 1s's, you went through both of them. Then you went through the 2s's. You went through both of them. Then you went through the 2p's. You only went through 1. So your picture is going to be, well, there's configuration either way. You're going to have one shell with 2, the next shell with 2, and then as the subshell, and then the outer subshell of that would be a 1. This also, I'm realizing, this explains why the first shell only ever holds 2. Like, even on the board drawings, the first shell only holds 2. Why does it only hold 2? I don't know, it just does. Well, it's only made out of an s orbital, so that's all it can hold. It's just what an s orbital holds. Outside of that is a bigger orbital of s. So you have a little sphere, and again, like, we're drawing rings just because it's 2D, but a little sphere with holding 2, and then around that a bigger sphere holding another 2, and then around that you've got one of the figure 8s holding 1. Alright, so another example. Let's do calcium. Right there. Calcium, element number 20. Oh yeah, again, for this, it's element 5, so when we get done, we should have 2, 4, 5 electrons accounted for. So that's what we have. So calcium, element number 20. Alright, so as we walk through the table, we start off with 1s, we go through 2 of them. You'll see after a while, like, that happens every time. 2s, you go through 2 of them. So if you can kind of just remember the order at the beginning, just add however much you need by the end of it. So 2p, we went through 6 of them. 3s, we'll pop down here. 3s, we went through 2 of them. That's where we're ending up. 3p, we went through 6 of them. And then 4s, we went through 2 of them. So let's write the electron configuration for calcium. It's this all strung together. In total, we have 10 and 10 electrons, so that's a total of 20. That's what we're looking for. So I like doing it this way. Do the configuration first, and then you can see on shell number 1, you have 2 electrons. On shell number 2, you have 6 electrons. On shell number 3, or sorry, you have 8. On shell number 3, you have 8. On shell number 4, you have 2. So that's how we have our picture. 2, 8, 8, 2, split into subshells on those. Alright, so now we get tricky. I want you to show me what it is for arsenic. I thought it was acetone. I was custom there. Arsenic right there. That's element number 33. So when you end up, you should have 33. Pay attention to that and realize that is the period where these 10 electrons will live. This is the period where these electrons live. Alright, so at this point you're probably really tired of having to write 1s2, 2s2, 2p6, that whole thing as you travel through here. So there is a shorthand way of writing it, because we know we've gone through all of this in order to get where we are. So what you do is you basically fast forward ahead and you end up right here. This is the last noble gas before the period that we care about. So if we went to figure out the configuration of that, for the shorthand, we would go with the previous noble gas. So what element is right there? That's going to be argon. So for shorthand, we say, all right, let's fast forward to argon instead of saying 1s2, 2s2, 2p6, 3s2, 3p6. So we'll just go right to 3p6, which is argon. Then we pick up giving our directions. So if somebody already knows how to get to the town you're talking about, you don't have to give them instructions to get there. So okay, so go to Abilene and then do this when you get there. So this is the, hey, we're there now, so now what? So 4s2, 3D, and there are 10 of them. Now, if we back up a little bit, we saw on this page 3D, or for the Ds, there are 10 of them. So that's where that number 10 comes from. That's how many electrons are held by that orbital. And then we are back in 4p, 1, 2, 3. So 4p3. One, 2, 3, 10, 4p3. Okay. So our picture of this basically corresponds to that. I just left up the other picture because the inside's exactly the same. We ended up with 4s2. That's what that is. 4s2. So after 4s2, we added a 3d10. So that does not mean that we added 3 electrons to the fourth shell, because it's not 4d10, it's 3d10. So that means outside of what we'd already drawn for that, we have another shell here. We have another shell here, and on that one we add another 10 electrons, and that is the 3d10. So we already had, for our 3s, we had 2. For our 3p, we had 6. Now we add on the 3d, on which we have 10. So total on the third shell, we have 18. I thought that was against the rules. Not anymore. Outside of that, then we have our 4s2, and to finish up for the one we're looking at, we ended up with 4p3. So 4s had 2, 4p has 3. So in total, that's where we're going to get our correct number. So for arsenic, that would be 33. So if you add all this up, that's what you'd end up getting, is 3 on the outer shell. Up until there basically equals 3. Okay. So if nothing else, that's a big, giant, hopefully helpful review on this stuff. Alright. Keep on keeping on.